Well, we're going to have a look at today the highest common factor and factorising using first of all the highest common factor which we have found before we try to factorise using that highest common factor. Okay, let's just do some definitions here. So, we're saying that the highest common factor means the factors which are present in all terms being considered. All of the terms have to have them, otherwise they don't count. For example, if we've got 100 and 75, those two numbers, and we want the highest common factor. Okay, now the first thing we have to do is we have to factorise both those numbers using a factor tree into their simplest, what I'll call prime building blocks. And these are the prime factors, which we will, as we will see. They are the simplest forms into which you can break up these numbers into their component parts. 100. If you do a factor tree on 100, you'll get 5 times 5 times 2 times 2, all prime numbers. 75, on the other hand, is 5 times 5 times 3. So, what is in common to both of those numbers? The HCF is all the numbers, or pronumerals for that matter, which are present in both. So let's have another look. We've got 100 is 5 times 5 times 2 times 2, and 75 is 5 times 5 times 3. So there's something in common to both, those 5, so we'll write that down. That's part of the highest common factor. Is there anything else that's in common to both? Yes, there's a 5, another 5. Now we put that one down. Now, is that all there is? I think so, because that 2 and that 2 don't have corresponding cousins over in the other number. So that's the end of the line, I think. So the highest common factor, therefore, must be 5 times 5, which is 25. And that's it. Isn't that easy? Let's try some more while we're on the roll. Find the highest common factor in each of the following. Okay, we've got 12, 16 and 56, and then we've got another one with some pronumerals in it which we'll tackle in due course. Let's do part A first. Okay, let's factor tree them. 12 is 2 times 2 times 3. I'm assuming you know how to do a factor tree. Yes, from a factor tree, that's right. And 16 is 2 times 2 times 2 times 2 from a factor tree. And 56 is 2 times 2 times 2 times 7. All prime numbers, you'll note. Let's go over the page. And there we've got those numbers and their building blocks. And let's just write it all out. There's 12. There's 16. And here comes 56. Now let's start picking off the common factors. There, those 2's are common to everything, so that goes as part of our highest common factor. Now, I can see another 2. Yes, that's very good. That's in common as well. But I don't think there's anything else in common. Can you see anything? No, I don't. I can't see anything. So I think we've reached the end of the line, and therefore, yes, our HCF, our highest common factor, is 2 times 2, or 4. Isn't that great? Now let's do part B now with these nasty looking pronumerals in it. The procedure is exactly the same. Exactly the same. So we'll basically split those terms into their simplest form. Now you'll see that I've split the 4 up as factor treated into 2 times 2, then times A, times B, and times C. And 6 BCD in its simplest form is similarly 3 times 2 times B times C times D. Now, what we've got to do is work out the highest common factor. Have a look. What's in common? I can see something. I can see, yes, the 2's. The 2's are in common. Now, let's now go into pronumeral land. Is there anything in pronumerals you can see? Yes, I can too. It's the B. And there's something else. What is that? Yes, it's the C. I think that's all now. So therefore, Yes, our HCF is 2BC for you and me. How easy is it? Now, what we've got to do now is we've got to factorise each of the following expressions by firstly finding the highest common factors and then using those highest common factors outside the brackets which we will create. Okay, you'll see, just have a look. Here's part A, 5x plus 15y. Okay, now let's do the old break them up into their simplest bits, and then we'll take out the common factors. Now I can see something in common, can you? Yes. So that is all there is, I think. So that's what we're going to use to take outside our bracket, and then what you put inside the bracket is what's left over after you take out the common factor, okay? And that's right, because if you actually multiplied that out again, you would see that what we would get is what's on the line above, so we haven't made a mistake. It's jolly good, isn't it? So there you are, that's that one. Let's do the next one now while we're on a roll. Some minus signs. They could create problems if we let them, but we're not going to let them, are we? Okay, let's do the old breaking it up into its building blocks. Yes, 14 is 7 times 2 times x times y, and the second term is 7 times y. Now, come on, have a look. What's in common? I can see a number and a pronumeral. Can you? Yes, there's the number, and so that comes... Oh, look, there's the pronumeral. So let's take them out, and what do we have left over? We have 2 times x and a minus sign from the first term. Now, from the second term, basically the minus sign is also there in front of the 7, so we've got to put that in. And if you take out 7 and y, it appears like there's kind of nothing left. But what you do is a little bit of smoke and mirrors, and you say, well, 7 times y is really 7 times y times 1, if it's all said and done, because the 1 doesn't change the value of it at all. So then you just, after you take the 7 times y out, you're just left with the 1, okay? Now, yes, what happens if we wanted, because really those minus signs are in common to both terms as well. So what if we wanted to take the minus sign out? Well, first of all, let me explain that what is written there is perfectly correct in itself, okay? But if you did want to take the minus sign out, you must be careful to change the sign of every term in the bracket, okay? It's very important. So what it does is it changes the first term from minus 2x to plus 2x, and the second term from minus 1 to plus 1. And that is the answer. Yeah, that's it. Beautiful, isn't it? Okay, I think we're going very well. Let's do C. We've got 3 terms there, some pronumerals and some numbers. Okay, there it is. Now, I'm going to break everything up into its simplest bits, and there it is. See if you agree with me. Yeah, I think that's pretty good. Now, you've got to look and see what's in common to all 3. I think I can see a number. Yes, I can. Now, can I see any pronumerals? Yes, I can. Can you? Well, here it comes. That's the number. Yes, it's 3. Is in common to all. And the B is in common to all. So that, I think that's all. So we'll put that out in the front of the brackets which we're going to create, and then put in the brackets what's left over, okay? Now, having done the hard bit, we'll get rid of the times signs because we don't need them anymore. And that's what you get. Isn't it beautiful? Truly beautiful. Now, I think we've just got D left to do now. Here comes D for you and me. 6x squared y plus 9xy squared. Okay, let's break it up. Break away. So now, do you agree with that? The 6 is 3 times 2, and the pronumeral, the x squared, from the first term is just x times x. That's the simplest way to express that. And the y squared from the second term is just y times y. And of course, the 9 in the front of that term is 3 times 3. Now, what have you got in common? I can see a 3. Yes, I can. And I can also see an X, I think. Yes. And I can see a Y. Oh, my goodness. We've hit the jackpot here. So let's take that out the front. That's 3 times X times Y. And then put in the brackets what's left. 2 times X plus 3. Oh, gee. Isn't that great? Now, let's dispense with the timeses because we don't need them anymore. And there you are. Isn't this great? So see, it's so easy to do. Look, you can do this standing on your head. Hey, and so can our Mr. Computer. He's very happy about that. So there it is. Now, go ahead and do any homework which you've been given and have a wonderful time. Okay? And we'll see you next time.